Okay, so you know what? I lied, but you know, like, that's just the way it is because I'm a guy and we lie. All right, so we're not going to do number 36. We're going to do from the conditional probability handout that we passed out in class, which is available on the wiki, and if it's not there at this moment, I will post it, but I'm going to post it before you see this anyhow, so it doesn't really matter. So shut up, nobody likes you. All right, so here we go. What we're going to do, oh, this isn't going to work. We got to start from scratch here. We're going to look at how many of these are there? Okay, there we go. That'll be fun. All right, we're going to look at number 2. And number 2 says, voters in a large city are 40% white, 40% black, and 20% Hispanic. A black mayoral candidate anticipates attracting 30% of the white vote, 90% of the black vote, and 50% of the Hispanic vote. And then there's questions, blah, blah, blah. All right, so here's what we have. We have 2 variables. And our 2 variables happen to be race, and we have to have voting preference. All right, so what we have here that makes this difference is this is not 2 choices on this variable over here. We have 3 choices. And our 3 choices consist of, well, we've got the population is black, the population is white, and the population is Hispanic. So I have 3 choices here, okay? So instead of being a 2 by 2 table, I've got 3 on this side, and then the candidate has to decide, oh, either the people are going to vote for him or they're not going to vote for him. Burp, excuse me. All right, and again, we've got totals. So this is the information that we have. Now we've got a 3 by 2 table here, which makes it a little more complicated. But it shouldn't be, all right? Voters in a large city are 40% white. Where is that going to go? Well, that's going to be the total of the white population is going to be 40%. They are 40% black, and they are 20% Hispanic. Okay, easy to do. Then it says, the candidate anticipates attracting 30% of the white vote. It does not mean that this is 30%. Because these are the people that are white and voted for him. It's not saying that that's 30%. It's saying 30% of the white voters are going to vote for him. So this is 30% of this value. So how do I find 30% of 40%? I multiply 0.3 times 0.4, 0.12. Okay? So I'm going to put the 1 down here for the total. Okay, so if 12% of the people are going to vote for him that are white, what percent aren't going to vote for him that are white? Well, that's, as we add across, down, we add across, so this is going to be 0.28 because 0.12 plus 0.28 is 0.40. Woo! Oh man, this is so hard, I'm sweating. All right, let's talk about the black voters. He's expecting 90% of the black vote. And again, obviously this can't be 0.9, but this is going to be 90% of the 40% that are black. So 0.9 times 0.4 is going to be 0.36, which means what percent is not going to vote for him that is black? That's going to be 0.04. Hispanic voters, he's expecting 50% of the Hispanic vote, or exactly half of this 20%. So this is going to be 0.10, and this is going to be 0.10. Now, what is the total of votes he's going to get? Well, 0.36, 0.12, 0.10, 0.58. The non-voters, 0.04, 0.28, 0.10. Yeah, I can add 0.42, and these add to 1, so I'm in really good shape. And our question here from the sheet is, what percent of overall votes does the candidate expect to get? Well, that's going to be this value right here of 58%. B, what percent, or what is the percentage of the population of both black and not voting for the candidate? Well, what's the percentage of people who are black and not voting for the candidate? That would be this right here, the intersection of the black and not voters would be 0.04. So let's add one more question in here. Oh, I never started the recorder. That's all right, I don't need it. Okay, so are these 2 variables, race and vote, independent of each other? And we can determine that by saying, okay, they would be independent if the probability of B given A is equal to the probability of B. And again, what we said is I can set up any conditional distribution I want. But the easiest thing here to do is to sit there and say, okay, I'm going to go with the first spot of the first row and set it up that way. Okay, so what's the first row? The first row is, for me, this happens to be the way I set this up, is black. So given that you are a black voter, so I would write this as given that you are black, what's the probability, the first spot in that is going to be, what's the probability that you voted for him? So that'd be 0.36. So 0.36, I'll write this as vote, has to be equal to what? Well, it's going to have to be equal to the probability that you voted for this guy. All right, so this is 0.40, this is 0.36, and the probability that you voted for this guy is 0.52. 0.36 divided by 0.40 is 0.9. Is that equal to 0.52? No, it's not. So therefore, these are not independent of each other. Okay, so then let's ask another question, just because we're here. And let's ask a question like this. We've got the conditional distributions based off black, of white, of Hispanic, because that's how we got these values. Let's change it the other way around. Let's say a question like this. What's the probability that you're going to be Hispanic given that you voted for this guy? Okay, given that you voted for this guy, there's my new population. My new population size is those that have voted, which is the total down here, which is 0.58, because as soon as I set this condition, I'm looking at this column saying we're right here, so what's the total of that? 0.58. Of that 0.58, how many people are Hispanic? How many meet the criteria of Hispanic? 0.10. So 0.10 divided by 0.58. I have no idea. I'm going to break out this calculator. Oh, it says old, really old Casio, but that's all right. And I'll say 0.1 divided by 0.558. Yeah, I can almost figure out what a 5 is. 0.58, and I've never done this problem before, is equal to 0.1724. And there it's done. So now we know how to do it with 2, and we know how to do it with 3, and I still hate those tree chart things. Okay, so there we go. Chapter 15, we're done. Woo! Chapter 16's next.